Hello everyone, here is Afra. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended. Paper code is 0625 with variant 41, held on May or June 2019. So let's start from question number 1. Question number 1. Rocket is stationary on a launch pad. At time t is equal to 0, the rocket engines are switched on and exhaust gases are ejected from the nozzle of the engine. The rocket accelerates upward. Figure 1.1 shows how the acceleration of the rocket varies time t is equal to 0 and time t is equal to tf. In the figure 1.1, from t is equal to 0 to tf, there is a graph that shows that acceleration varies with time. So first of all, the rocket is moving with increasing acceleration from this point, and after that point the acceleration of this rocket is constant. So part A, defined acceleration. Acceleration is the gradient of speed time graph, or we can define the acceleration is the rate of change of velocity of the body. So I write here acceleration A is equal to V, that is velocity, over time. So we can simply say that the rate of change of velocity of body is acceleration. Part B. On figure 1.2, sketch a graph to show how the speed of the rocket varies between time t is equal to 0 and time t is equal to tf. Here we have to show that how the speed of the rocket varies when the acceleration time graph is given. So going back to the figure 1.1, we can see that if I consider it's a point A, and this point is B and C. So we can see here that from point A to B, the acceleration of rocket goes on increasing because rocket accelerates. And from B to C, the acceleration of a car is constant. It means that its acceleration is not changing. So when I draw the speed time graph, it will be from this formula. We know that acceleration is the gradient of speed time graph. So when we draw the gradient of this increasing acceleration, it will be curved. And I am going to draw this. Starting from the initial point, this graph will be just like this, which shows that the acceleration of the acceleration of the rocket is increasing. Secondly, we can see that from B to C, the acceleration is constant. It means that the velocity should be uniform. Uniform velocity means constant acceleration. And the uniform velocity is basically if a body covers equal distance in equal interval of time, then we can say that it is moving with uniform velocity. So when we have to draw for the uniform velocity, it will be just like a straight line that rises both in x and y axis, and it will be just like this. So this curve shows that the speed time graph, the acceleration is constant but its speed is uniform. So this graph is a complete representation of the acceleration time graph. Going towards the next part. And I've also mentioned here point A is this is point B, and this is point C. From point A to B the slope is increasing, and from B to C the slope is constant, because from B to C the acceleration is constant. Part C. Sometime later, the rocket is far from the Earth. The effect of the Earth's gravity on the motion of rocket is insignificant. It means that we have neglected the gravity. As the rocket accelerates, its momentum increases. When rocket accelerates, its momentum increasing. Part 1. State the principle of conservation of momentum. Here we have to state the principle of conservation of momentum. So according to this principle, the total momentum of the isolated system remains constant. It means that the total momentum before and after the collision is constant. So I write here, in any isolated system, the total initial momentum is equal to the total final momentum. Part 2. Explain how the principle of conservation of momentum applies to the accelerating rocket and the exhaust gases. So according to law of conservation of momentum, the total momentum after and before remains constant. So if I consider that initial momentum is Pi and final momentum is Pf. So Pi, that is the initial momentum, it will be equal to final momentum. If I consider a rocket, we know that the rocket moves by burning gases through the engine, and these gases are exhausted from the back of this engine. So when the rocket accelerates upward, it means that more gases are exhausted from the backward of this rocket. So the total initial momentum must be equal to the total final momentum. So how this momentum equal? It means that if the rocket accelerates in upward direction, there will be the gases that exhaust from this rocket in the downward direction. Now I am going to draw their direction. As the rocket moves upward, it's a force that is moving the rocket in upward direction, but the gases are expelled in downward direction. Both of these forces are equal. That's why the momentum after is also equal, so that when both of these forces are equal magnitude, they cancel each other, so that the initial momentum becomes equal to the final momentum. So I write here, according to conservation of momentum, the rocket gains momentum by ejecting exhaust gases that is equal to the momentum in opposite direction. so that the initial and final momentum remain same and the total momentum of this system is conserved. Question number 2. Figure 2.1 shows a sign that extended over a road. Here is the figure 2.1 and we can see that it's a weight that is acting in downward direction and the weight of this sign that is acting in downward direction, and it's a P, which is the pivot point, and the distance from this point to the pivot point is 1.3 meter, while the distance from this point to the weight is 1.8 meter. There is also a concrete block that is placed on the left hand side and its distance from this is 70 centimeter. The mass of the sign is 3.4 into 10 to the power 3 kg. Part A. Calculate the weight W of the sign. Here we have to calculate the weight of the sign. And we know that weight is the product of mass and G. That is acceleration due to gravity. Mass is given, that is 3.4 into 10 to the power 3. And the value of G is 10. So the weight comes to be 3.4 into 10 to the power 4 newtons. The weight of this sign is 3.4 into 10 to the power 4 Newton. Right here 3.4 into 10 to the power 4 newtons. Part B. The weight of the sign acts at a horizontal distance of 1.8 meter from the center of the support post and it produces a turning effect about the point P. Point P is a horizontal distance of 1.3 meter from the center of the support post. Part 1. Calculate the moment about P due to the weight of the sign. Here we have to calculate the moment. And we know that moment is the product of force and the perpendicular distance from the pivot point. I write here moment. It is equal to the product of force and the perpendicular distance from the pivot point. So here we have to calculate the moment due to weight. So going back to the diagram, we can see that the weight of the sign is acting downward and it is represented by W. Now we have to calculate its distance from the pivot point, that is P. So first of all we extend it in downward direction. So it will be just like this. Now this is the point P. We have to calculate this distance, that is the perpendicular distance of the weight of sign from pivot point. Now we can see that the distance from this point to this is 1.8 meter, while the distance from this point to this is 1.3. We have to calculate this distance and it will be equal to 1.8 minus 1.3. and it is equal to 0.5. So the perpendicular distance of this sign from the pivot point is 0.5. So I write here the perpendicular distance is 0.5 and we have to calculate for the weight. That's why the force is equal to weight. I write here force is equal to weight. So the weight is 3.4 into 10 to the power 4 multiplied by the perpendicular distance is 1.8 minus 1.3 and the moment comes to be 1.7 into 10 to the power 4. So I write here the unit of this is Newton meter. The moment is equal to 1.7 into 10 to the power 4 Newton meters. Next part 2. A concrete block is positioned on the other side of the support post with its center of mass on a horizontal distance of 70 cm from the center of the sport post. Part 1. State what is meant by center of mass. So, center of mass is basically the point where the all mass of the object is considered to be concentrated. So, I write here, we have just write its definition because it's a 1 mark question. So, the point where all the mass of body is concentrated. So this point is known as the center of mass. Part 2. The weight of the concrete block produces a moment about point P that exactly cancels the moment caused by the weight W. So, calculate the weight of the concrete block. So, we have to calculate the weight of concrete block. In this statement, it is said that the total moment is conserved. It means that the clockwise moment is equal to anti-clockwise moment because the moment about the point P due to the concrete block cancelling the moment caused by the weight. That's why the total clockwise moment will be equal to the total anti-clockwise moment. So first of all, going back to the diagram, we can see that the weight is acting in downward direction. So it causes a moment in clockwise direction just like this, while the box is on the left hand side and it moves in this direction. So the moment will be anti-clockwise. And both of these moments must be equal, according to law of conservation of moment, that the anti-clockwise moment will be equal to clockwise moment. I write here anti-clockwise moment will be equal to clockwise moment. In this case, the clockwise moment is caused by the weight and the anti-clockwise moment is caused by the block. So we know that the moment of weight that we already calculate, it is equal to 1.7 into 10 to the power 4. I write here it is equal to 1.7 into 10 to the power 4. And the anti-clockwise moment will be equal to the product of perpendicular distance from the pivot point and its weight, because here we have to calculate weight. That's why first of all we find out its perpendicular distance. So going back to the diagram, we can see here that the block is situated at this position and we have to calculate its distance from the pivot point P. So we can see that the distance from this point to this is 70 centimeter. First of all, we have converted this centimeter into meters and it will be 70 divided by 100. It will be equal to 0.7. So the distance from this point to this is 0.7 and the distance from this point to this is 1.3. So we add these two distances to get the perpendicular distance of the concrete block from the pivot point. So it will be equal to 1.3 plus 0.7 and it is 2 meters. So the perpendicular distance is equal to 2 meters. I write here it will be equal to 2 multiplied by weight is equal to 1.7 into 10 to the power 4. Here we have to calculate weight. It will be 1.7 into 10 to the power 4 divided by 2. And the answer comes to be 8.5 into 10 to the power 3. The unit of weight is Newton. So I write here 8.5 into 10 to the power 3 newtons. Part C. The concrete block is removed. The sign and support post rotates about a pivot point P in a clockwise direction. So both the sign and support move in a clockwise direction when the concrete block is removed. State and explain what happened to the moment about point P due to the weight of the sign as it rotates. So first of all, going back to the diagram again. Now here is the situation when we have removed this block. This block is removed. We just ignored this one. And what will happen? So we know that the weight causes the clockwise movement. And when the block is removed, the moment of the weight increases. And how it increases? Because the distance of the weight from the pivot point increases. And as the object is toppled, weight position will shift to right hand side. First of all, weight position, I consider that it's the position of weight. Now when it is toppled, then it may shift to some other position like this. And the pivot point is at this position. So its distance increases as compared to this distance. By increase in distance, we can say that the moment increases. So I simply write here that the moment increases when we remove the block. So the moment about P due to weight increases. Because the distance between the weight and pivot point is increasing. So I write by increasing distance between weight W and pivot P. So in this case, the moment about the point P, that is due to the weight, increases. Question number 3. A cube of size 0.040 meter is floating in a container of liquid. Figure 3.1 shows that the surface of liquid is 0.028 meter above the level of the bottom face of the cube. The pressure of the air above the cube exerts a force on the top surface of the cube. The valve is closed. Part A. Explain in terms of air molecules how the force due to the pressure of the air is produced. Here we have to explain that how the force produced due to the pressure. So here we can see in the figure 3.1 that there is a container and there is a air that is outside of this system. And we know that there are large number of molecules, that is of air molecules. And if you consider that I have this system in which there are large number of air molecules, and we know that the molecules are in constant random motion. They collide with each other and also collide with the wall of this container. When they collide with this wall, they change their direction at every collision. So there will be the change in momentum. When they change their direction, there will be the change in momentum. I write here change in momentum delta P. So we know that the rate of change of momentum is actually equal to the applied force. It means that when the molecules collide with the wall of container, they change their direction and it will causes a change in momentum due to which the force is produced. And we know that F is equal to delta P over delta T. This force actually causes the pressure because pressure P is equal to force per unit area. That's why the force is exerted due to the pressure on the air. So I write here air molecules move randomly. and collide with the wall of container. And they change their direction, or we can say that they bounce back. When they bounce back, there will be the change in momentum. Change in momentum, there will be the force exerted on the air, and we know that as pressure is equal to force per unit area, that's why there will be the pressure. So part B, the density of the liquid in the container is 1500 kg per meter cube. Calculate part 1. The pressure due to the liquid at the depth of 0.028 meters. Here we have to calculate the pressure when the density is given, and we know that the pressure P is equal to the product of density, gravitational acceleration and height. We have to calculate this pressure where the density is given, that is 1500 kg per meter cube, and the depth is also given 0.028 meter. In this case, the age that is represented here is actually the depth. So by putting values, rho that is 1500 multiplied by 10 and height is 0.028 meters. So it comes to be 420 Pascal. Here pressure comes to be 420 Pascal. Part 2. The force on the bottom face of the cube caused by the pressure due to the liquid. Here we have to calculate the force, and we know that pressure is equal to force per unit area. Here we have to calculate force, and it will be equal to product of pressure and area. So we have to calculate the force, and this pressure is basically due to the liquid that we already calculate. It is 420 multiplied by area. So here we have to calculate area. Going back to the figure, we can see that area will be equal to L square, means that the square of one side length. So the side length is given 0.040 meters. We just take the square to calculate area. So I write here 0.040 square. So the force comes to be 0.67 Newton. The value of force due to the liquid is 0.67 newtons. Going towards the next part, part C. The valve is opened and the liquid is pumped into the container. The surface of the liquid rises a distance of 0.034 meters. The cube remains floating in the liquid with its bottom face 0.028 meters below the surface of liquid. Part 1. Calculate the work done on the cube by the force in B. Part 2. So here we have to calculate the work when a force is given in part B2 that we already calculate. So we know that the work is the product of force and distance. Force is given in the B part 2, that is 0.67. I write here 0.67, and the distance is also given, that is equal to 0.034. So it will be 0.034. the work done comes to be 0.023 joules. So the unit of work is joule. So I write here work done is equal to 0.023 joule. Part 2. Suggest one reason why this is not an efficient method lifting up the cube. So this method is not efficient. We have to explain its reason. Going back to the diagram, we can see here that when we have to lift this cube, we have to lift the liquid as well, because there is a liquid inside this cube. So when we do work, we have to supply energy to lift the cube and the liquid as well. And there must be enough energy. That's why this system is not too much efficient, because energy will be used to lift the both cube and liquid. I write here energy will be used to lift both cube and liquid. And second reason is that some energy might be lost due to the friction between liquid and pipes. So I am also writing this one. Some energy might be lost due to the friction between liquid and pipe. So that's why this method is not efficient for lifting up the cube. Question number 4. Gas of mass 0.23 gram is trapped in a cylinder by a piston. The gas is at atmospheric pressure, which is 1.0 into 10 to the power 5 Pascal. The value of atmospheric pressure is given. Figure 4.1 shows the piston held in position by a catch. So in a figure 4.1, we can see that here is a heater that is attached at this position, and there is also a catch. The inside here is a gas and it's a piston. The air at atmospheric pressure. And these are the cylinders. The volume of the trapped gas is 1.9 into 10 to the power minus 4 meter cube. The volume is given as the electrical heater is used to increase the temperature of the trapped gas by 550 degrees C. So part 1. The specific heat capacity of the gas is 0.72 joule per gram per degree C. Part 1. Calculate the energy required to increase the temperature of the trapped gas by 550 degrees C. Here we have to calculate the value of energy that is required to increase the temperature of the trapped gas. And we know that the energy, that is E, it will be the product of mass M. I write here E is equal to M C delta T. Here M is the mass and C is specific heat capacity and delta T is change in temperature. We have to calculate energy that is given by E. So mass is given in this question, that is 0.23 gram. So I write here 0.23 multiply by specific heat capacity is 0.72 multiply by the change in temperature is 550 degrees C. So the amount of energy comes to be 91 joules. So I write here energy is equal to 91 joule. Part 2. The power of heater is 2.4 watt. Here the power of heater is given, that is 2.4 watt. Part 1. Calculate how long it takes for the heater to supply the energy. Calculate in A part first. Here we have to calculate the time. So we also know that power is equal to the rate of doing work or energy per unit time. Here we have to calculate time. Time will be equal to energy over power. So we have used the value of energy given in part A1, that is 91 joule. So I write here 91 divided by power is 2.4 watt. It will be 2.4 and the time comes to be 37.95 seconds and this is approximately equal to 38 seconds. So I write here time t is equal to 38 seconds. Part 2. In practice, it is much longer to increase the temperature of the gas by 550 degrees C using the heater. Suggest one reason for this. So going back to the diagram, we can see that the heater takes some time to heat up because the heat may be lost to the surrounding or energy is used to increase the temperature of piston and cylinder as well. So here is the piston. The energy that we supply is used to increase the temperature of this piston and also the cylinder. That's why it takes time to heat up. I write here thermal energy is used, that is heat energy. To increase the temperature. Of piston and cylinder. That's why it takes time to heat up. Going towards the next part B. When the temperature of gas has increased by 550 degrees C, its pressure is 2.9 into 10 to the power 5 Pascal. The catch is then released, allowing the piston to move. As the piston moves, the temperature of the gas remains constant. State and explain what happened to the piston. So going back to the diagram, here atmospheric pressure is given, that is 1.0 into 10 to the power 5 Pascal. And when the inside pressure is also equal to the atmospheric pressure, then the catch keeps its piston. But when the pressure inside this cylinder is increased and its value given, that is 2.9 into 10 to the power 5, I write here the pressure again is 2.9 into 10 to the power 5 Pascal. So first of all pressure is this, but again pressure increased, and this increased by removing the catch. Then what will happen? There is a resultant pressure that is acting on this in a right direction. The pressure will be in this direction. That's why the piston will pull in the right direction away from the heater, because the pressure inside this cylinder is larger as compared to the atmospheric pressure. So I write here, we have to state and explain what will happen to the piston. So the pressure inside piston is greater than the atmospheric pressure. So there is a resultant pressure to accelerate the piston to right. So we can simply say that the piston will move in right direction away from the heater. Part 2. Determine the volume of the gas when the piston stops moving. So here we have to calculate the volume. When the piston stops moving, it means that we have to calculate the final volume. And in the question it is said that the temperature is constant. It means that we have to use the Boyle's law, according to which pressure is inversely proportional to the volume by keeping its temperature constant. So according to Boyle's law, we write P1 V1 is equal to P2 V2, where P is the pressure and V is the volume. Here we have to calculate the value of V2. It will be equal to P1 V1 over P2. So the first pressure is 2.9 into 10 to the power 5, and the volume is also given, that is 1.9 into 10 to the power minus 4, and the P2 pressure is 1.05 into 10 to the power 5. It is 1.0. So after calculation we get the volume comes to be 5.5 into 10 to the power minus 4 meter cube. The unit of volume is meter cube. So I write here 5.5 into 10 to the power minus 4 meter cube. That is the volume of the gas when the piston stops. Question number 5. Liquid and gases are two states of matter. In both boiling and evaporation, the liquid changes into a gas. State two ways in which the boiling differs from evaporation. So here we have to differentiate between the boiling and evaporation. So the boiling is a constant temperature process, while the evaporation causes the liquid to cool. Or we can simply say that in the boiling the temperature remains constant. So I write here boiling is a constant temperature process, while the evaporation causes the liquid to cool. It means that it decreases the temperature of liquid. Second point is that the boiling occurs at only one temperature, that is boiling point, while evaporation can occur below the boiling point. I write here boiling only occurs at boiling point, while evaporation can occur below boiling point. Part 2. Before injecting a patient, a doctor wipes a small amount of a volatile liquid onto the patient's skin. Explain in terms of molecules how this procedure cools the patient's skin. So here evaporation is happening. What happens in the evaporation? If I consider that it's a surface on which there are large number of molecules. So the high energy molecules lies at the surface. The surface on which the molecules are high energy, they escape from this surface. The high energy molecules escape from this surface, leaving behind the low energy molecule. So the speed of these molecules also be small because their energy is small. When the speed is small, then the kinetic energy is also small, because kinetic energy is equal to half mv square. When speed is small, kinetic energy also be small, and kinetic energy is related with the temperature. I simply say that temperature is directly proportional to kinetic energy. When kinetic energy is smaller, temperature also be low. As a result, there will be cooling. So I write here, during evaporation, high energy molecules escape from surface. This causes the liquid average kinetic energy to decrease, and so the liquid temperature drops. Then heat is conducted from patient's skin. As a result, there will be cooling the skin. Part B. Gases can be compressed while liquid are not. Explain in terms of molecules why the liquids are incompressible. So we can compress the gases, but we cannot compress a liquid. We have to explain its reason. Because we know that the molecules of gas are very far from each other. The distance between the gas molecules are very large, and the distance between the liquid molecules are very small. These molecules are touching to each other and there is no space between them so that they can compress. And there is also the large repulsive intermolecular forces between these molecules, so it is very difficult or it's even impossible to compress a liquid. So I write here, in liquid, molecules are touching and there is no space between them. If you try to compress a liquid, there will be large repulsive intermolecular forces. So that's why it's very difficult to compress liquids. Question number 6. Green light of frequency 5.7 into 10 की power 14 Hz is traveling in air at a speed of 3 into 10 की power 8 meter per second. The light is incident on the surface of the transparent solid. Figure 6.1 shows the wavefront and the direction of travel of the light in the air. So it's the direction of travel and these are the wavefront. And this is the air medium, while below this line it's a solid. The light travels more faster in the transparent solid. The light travels more slowly in the transparent solid. Part A. Explain in terms of wavefronts why the light changes direction as it enters the solid. You may draw on figure 6.1 as a part of your answer. So first of all, we have to explain that why the light changes its direction as it enters the solid. So here we can see that there are two medium. First is air and second is solid. When this light comes from air into the solid, its direction changes and it will be refracted so that the direction will be just like this. So in this case, the direction of this wave changes. We have to explain why the direction changes. I consider that it's the A end and this is B of this wavefront. The end of the wavefront A hits the boundary first before A. The end of the wavefront A hits the boundary first before B. So you can see here that this is the A and it hits the boundary first as compared to B. The wave slows down after crossing the boundary because here is a solid and it's a denser medium. But the end A spent longer in the slower material. The difference in the time in the slower substance causes the wavefront to change its direction. So I write here the end of the wavefront A hits the boundary before B. The wave slows down after crossing the boundary but end A spends longer time in the slower material. The difference in time in the slower substance causes the wavefront to change direction. Part B. The refractive index of the transparent solid is 1.3. Part 1. The light is incident on the surface of the solid at an angle of incidence 67 degrees. Calculate the angle of refraction of the light in the solid. Here we have to calculate the angle of refraction. And the index of refraction is given and the angle of incidence is also given. So by using that, refractive index is the ratio of sine of angle of incidence over sine of angle of refraction. Here we have to calculate the value of r. That's why sine of r is equal to sine of angle of incidence over n. And angle of incidence is 67 degrees and n is 1.3. So angle of refraction will be sine inverse of sine 67 degrees over 1.3. So that the angle of refraction comes to be 45 degrees. I write here 45 degree. Going towards the next part of this question. Part 2. Determine the wavelength of the green light in the transparent solid. Here we have to find out the wavelength of the green light in a medium that is transparent solid. We know that V is equal to F lambda, where V is the speed, F is frequency and lambda is wavelength. We have to calculate lambda. It will be equal to V over F. For that we have to find out the value of V and F. In a question, it is given that the speed of this light is 3 into 10 to the power 8 meter per second and it is in a medium air. We have to find out this speed into solid. For that, I use that n is equal to C over V. That is, the index of refraction is equal to the ratio of speed of light to the ratio of speed in any medium. From here we can calculate the value of V. It will be equal to C over n. By using this formula, we can find out the value of velocity in solid. So by using this, I can write V is equal to C over n and C is 3 into 10 to the power 8 and the index of refraction, it is given as 1.3, which is also refractive index. I write here 1.3. So the value of V comes to be 2.33 into 10 to the power 8 meter per second. We use this value of speed. It will be 2.33 into 10 to the power 8 meter per second and the value of frequency is also given. It is 5.7 into 10 to the power 14 Hz, which is also in the air. But we know that the frequency remains same. It remains same in air and solid. That's why I write 5.7 into 10 to the power 14. F is equal to 5.7 into 10 to the power 14 Hz. And the final wavelength will be 4.0 into 10 to the power minus 7 meter. So this is the value of wavelength. I am going to write here that wavelength is equal to 4.0 into 10 to the power minus 7 meters, which is the wavelength of green light. Question number 7. Figure 7.1 shows a circuit diagram that includes component X. In the figure 7.1, there are different components. We can see that the 30 ohm resistance is in parallel with component X, and this parallel combination is in series with 20 ohm resistance and ammeter. Ammeter is a device that is used for the measurement of current. And there are batteries that is connected here. State the name of component X. We have to tell the name of component X. From its symbol, we can guess that this component is thermistor. I write here thermistor. Part B. The electromotive force EMF of the battery is E. The switch is closed. Switch is closed, it means that the current is flowing through the circuit. The potential difference PD across a 30 ohm resistor is V30. The potential difference across the 20 ohm resistor is V20. The potential difference across the component X is Vx. State an equation that relates Vx to part 1 V30. Going back to the figure 7.1, we can see here that the electromotive force of the battery is E. It means that here is electromotive force and it is represented with E. The potential difference across 30 ohm resistor is V30. Here the potential difference is V30. The potential difference across 20 ohm resistor is V20. I write here V20. And the potential difference across component X is Vx. Here is Vx. We have to relate the Vx, this one, with V30. We can see that the X and resistor 30 ohm are in parallel combination. And I write here in parallel and series combination. Which thing remains same and which changes? First of all, here is current and second is potential difference. In the parallel combination, the current is different, while in series the current is same. So the potential difference here is same, but in series combination its value is different. From this we can guess that the potential difference in the parallel combination is same. It means that the potential that is across 30 ohm resistor will be equal to the potential difference across X component. I just write that Vx will be equal to V30. That is for the parallel combination. So in the first part I write that Vx, it will be equal to V30. Part 2, E and E20. Now we have to relate the Vx with E and 20. So here is a figure 7.1. In this figure, this parallel combination of X and 30 ohm resistor, it is in series with 20 ohm resistance and battery of EMF E. So when I combine this parallel combination, I suppose that it is the parallel combination, it's the output, and this is in series with V20. I let that it is equal to Vx, and this is again in series combination with battery. So all of the circuit is in series combination, and in series we can see that the current remains same but the potential difference value different. It means that we have add all of the potential difference that is equal to the total EMF of the battery. I write here for the series combination E, that is the EMF of this battery, it will be equal to Vx, that is the potential difference across parallel combination, plus V20. Here V20 is the potential difference across 20 ohm resistor. Here we have to relate it. So I write here Vx, it will be equal to E minus V20. So by this equation we can relate the potential drop across X component to the total EMF of the battery and the potential difference across 20 ohm resistor. So I write here it will be equal to E minus V20 is equal to Vx. So going towards the next part of this question. Part C. The EMF of the battery is 6.0 volt and the resistance of component X is 15 ohms. Calculate part 1. The total resistance of the circuit. Here in this part we have to calculate the total resistance of the circuit. So going back to the diagram, it is given that the resistance of X component is 15 ohms. We know that in a parallel combination, when we have obtained the resistance, that is equivalent resistor, it will be equal to the sum of the reciprocal of resistance of all components. Here component X and 30 is involved, that's why I write here 1 over Rx plus 1 over R30. So first of all we have to calculate R equivalent. 1 over R EQ, it will be equal to 1 over Rx is 15 ohms plus 1 over R30 is 30 ohms. So when we simplify this, R equivalent comes to be 10 ohms. No, this resistance is basically equal to 10 ohms and it is 20 ohm. You can see that this 10 ohm resistance is in series combination with 20 ohm. And in the series combination, we just add the resistance of individual component to get the total resistance. So I write here R, that is the total resistance. I represent it with RT. It is equal to REQ plus R20. It is 10 plus 20. The whole will be equal to 30 ohms. So 30 ohm is the resistance of this whole circuit. So I write here the total resistance comes to be 30 ohms. In the part 2, we have to calculate the ammeter reading. We know that ammeter is a device that is used to measure the current. It means that we have to measure the current through the circuit, and EMF of battery is given 6 volt. By using this value of EMF and the resistance, that is equivalent resistance, the resistance of whole circuit we already calculated. I just write that V is equal to IR. Here we have to calculate current. It will be V over R. So the voltage is 6.0 divided by resistance is 30. And the current comes to be 0.2 amperes. So the reading of ammeter is 0.2 amperes. Part D. The temperature of component X increases. State and explain what happened to the ammeter reading. So X component is basically thermistor. When the temperature of thermistor increases, its resistance decreases. I write here temperature increase, then its resistance decrease. Both of these have inverse relation with each other. Now how the resistance is related with the current. The EMF of the battery is given 6 volt, which is fixed. Its value is constant. By using Ohm's law, V is equal to IR. Here V is constant, so we can simply say that R is inversely proportional to current. When the resistance decreases, it means that the current in the circuit increase. I write here current increase, and the current is measured with the ammeter, so the ammeter value increases, or the ammeter gives greater reading. So we can simply say that by increasing the temperature of X component, the reading on the ammeter increases. I write here resistance of thermistor decrease. So that the circuit resistance decrease. Here one component resistor decrease means that the resistance of whole circuit decrease. So that the resistance of whole circuit decrease. Next, if R decrease but the potential difference is constant, the current also increases. So in this way the ammeter reading will also increase. Question number 8. A student turns the handle of an alternating current AC generator and rotates coil. Figure 8.1 represents the structure of AC generator. Here is a figure 8.1 in which we can see that there is a AC generator and it has different components. A coil is placed between the magnetic field, this is the coil, and this is placed in the magnetic field. North and south are the poles of the magnetic field. There is also a slip ring pair. Here these are the slip rings and the output voltage is taken across these. There is also the pair of brushes. Part A. There is the alternating voltage output between the two terminals. 1. Explain why the rotating coil produces our output voltage. So when we rotate the coil, there will be the output voltage. We have to explain that how the coil rotates, the output voltage is produced there. So there is a process of electromagnetic induction that when we change the coil position, then there will be the maximum number of lines or no number of lines cuts magnetic field, and there will be the output voltage, that is EMF. We can simply say that the coil cuts through the magnetic lines, inducing the EMF in the coil. This is according to electromagnetic induction. When this coil moves, we can see in this position it is in horizontal. So the magnetic field is always from north to south pole, and the coil is moving here perpendicular to field, and it cuts the maximum lines per second. It means that there is a maximum flux. Flux is the total number of lines. So it cuts the maximum lines per second, so there will be the maximum flux. So we can simply say that there will be the induced EMF in the coil due to the motion of this coil. I write here the conductor cuts or the coil cuts through the magnetic field. It means that the magnetic lines or force are changing there, and their number is maximum, or we can say that there is a maximum flux. So this induces the EMF in the coil. Part 2. State the position of the rotating coil when the alternating output voltage is a maximum value and explain why the maximum output occurs at this position. So we have to explain the position when the output voltage is maximum. So in a figure we can see that the coil is horizontal position. So there are basically two positions, when the coil is in horizontal position and when it is in vertical position. Now I will draw the horizontal position of the coil. This is north and south pole, and the coil is placed inside this magnetic field. So we can see here that the coil is moving perpendicular to field. Coil moving perpendicular to field. When the coil motion is perpendicular to field, it means that the maximum flux lines per second are cutting there. It means that there is a large amount of flux associated with this. And when there is a large amount of flux, so that the output voltage will be maximum, and it is in horizontal position. Now I consider another case when it is in vertical position. Again consider two poles. This is north and it is south pole. This is the coil. When it is placed in a coil, there is also the force that is exerted on this coil. And we know that the coil here is moving parallel to the field. So there will be no cutting of magnetic lines of force, or the flux in this case will be equal to 0. So there will be no generation of induced EMF in the case of vertical position. So their flux, that is represented by phi, it is equal to 0. But here flux is maximum. So I write here horizontal position that is the current position of the coil. When conductor moves perpendicular to field, and maximum flux lines are cutting per second. It means that flux is larger, due to which there will be the induced EMF. Part B. A lamp and an open switch are connected in series to the output terminal of the AC generator. The switch is closed and the lamp lights up. The student has to apply a greater force on the handle. Explain why a greater force is needed to keep the lamp lit. So here we can see that the lamp and an open switch, it is connected in a output terminals of the AC generator. So AC generator is actually a device that is used to convert the mechanical energy into electrical energy. It means that the coil moves in the magnetic field, which means that the coil does work, and this work is actually converted into the electrical form, that the lamp or any switch lit. So it means that the student must input more energy to lit the bulb, and so they must have to do more work. So I write here, the student must input more energy to lit bulb our lamp and they must do more work. Because lamp is connected with the output terminals, it means that we have to do more work to lit this lamp. As a result, the student applies more energy. Question number 9, part A. Figure 9.1 shows a beam of alpha particles moving towards a thin sheet of gold in a vacuum. So here is a vacuum. Inside this we place a gold sheet and alpha particles are falling from left to right on this sheet. And there are different detectors that are placed at different positions. Detectors in the region surrounding the thin gold sheet detects the alpha particles and determine the number of particles that travel in various directions. State and explain what can be deduced from the following observation. Part 1. The majority of alpha particles pass through the gold sheet undeflected and are detected on the far side. Deduction and explanation. So here alpha particles are helium nuclei and these are positively charged. It's a alpha particle, its atomic number is 2 and mass number is 4. And the number of proton in the helium is 2 while the number of neutron is also 2. So the majority of alpha particles pass through the gold sheet undeflected and these are detected on the far side. They pass undeflected. It means that the size of nucleus is very small, or we can say that the most space inside the atom is empty. So that's why the alpha particles pass straight forward and they do not get any deflection. I write here nucleus is very small. In the explanation, I write that the majority alpha particles have experienced no force. Because the size of nucleus is very small, that's why the most of them pass as it is in straight path. I write here majority alpha particles have experienced no force. So most of them do not pass near nucleus. They move in a straight path and remains undeflected. Part 2. A small number of alpha particles are deflected as they pass through the gold sheet. No, here is a deflection of alpha particles. It means that the nucleus is charged. We know that the alpha particles has charge. It is a charged nuclei. That's why if it gets deflection, it means that it collides with the nucleus which is also charged. So I write here nucleus is charged. And in explanation, alpha particles are charged so that they exert force on the alpha particles and nucleus must also be charged. I write here alpha particles are charged so they experience a force. That's why they get deflected when they pass through the gold sheet. Part 3. A very small number of alpha particles are deflected through very large angles are returned back the way they came. Reduction and explanation. So, here most of the alpha particles deflected at larger angles and they come back the way they came. So, it means that the nucleus is very massive as compared to alpha particle. So, I write here the mass of nucleus is very large as compared to alpha particle. That's why these are deflected at larger angle or come back. So I write here nucleus is massive than alpha. Particles. So in the explanation I write that alpha particles move and nucleus stays still. It is because that the nucleus is very massive, that's why it stays still. But the alpha particle move because its mass is very small as compared to nucleus. Next part, B. A beam that consists of both alpha particles and beta particles is passed through a region of space where there is a magnetic field perpendicular to direction of the beam. State two ways in which the deflection of alpha particles differ from the beta particles. First of all, the alpha particles are positively charged and beta particles are negatively charged. So when they pass through the magnetic field, there will be deflection and both of them are deflected in opposite direction because of the opposite sign of charges. So first of all, I write here deflect in opposite direction. And the alpha particles are very massive as compared to beta particle, and the alpha particles have very small deflection as compared to beta particle. So I write here much smaller deflection. So these are the two ways in which we can differentiate the alpha particle deflection from the beta particle.